In this video, we will extend our understanding of the difference between variables, parameters, and attributes in a class and what the scope is for each of them. We will also learn what shadowing is and how to avoid it. In a previous video, we discussed the scope and said that it's the part of the program that has access to the variable's content. We said that variables defined inside a method are called local variables because they are local to the method. We also said that the scope of a variable is from the end of the line at which it was declared to the end of the method. Attempting to use a variable before it's declared will cause an error. Now that we know how to write a class, we want to expand our understanding of the scope within a class, not just the method of the class. This is the rectangle class with a few of its methods: the set, setWidth, and getArea methods. The first type of scopes that we will discuss is the one that we are familiar with, the local variables of a method. In the case of the getArea method, the area variable is declared within the method, and that's why it's called a local variable. The scope of the area local variable extends to the end of the getArea method. The second type is the parameter variable, which is part of the method header. This type of variable is similar to local variables in that its scope is within its method. The only difference is that since it's declared in the header, its scope spans the method from the opening to the closing braces. That's why it's safe to use the same parameter variable with the same name in a different method, such as the set method in this case. The last type is the class attributes or the instance fields. An attribute has the broadest scope. It starts from its line of declaration to the end of the closing bracket of the class. It's visible to all methods. Now, the fact that the instance field is visible to all methods can cause a problem. When you declare a local variable in a method with the same name as the class attribute, the problem will occur. Interestingly, Java will not complain. Take the setWidth method for example. We define the local variable that is called width, which matches the name of one of the attributes. Then in the setWidth method, we say that width is equal to new width, which is the parameter variable of the method setWidth. Now the question is, which width will be set to the new width? Is it the instance field or the local variable? Java will choose the local variable because it's closer. Consider another scenario. This time, we declare a method's parameter variable to have the same name as the instance field length. Once again, Java will choose the length parameter variable over the field. So it will be as if the method variable length is set to itself, and the instance field will remain unchanged. In general, when a local variable or a method parameter variable takes the place of an instance field, we call this shadowing. We say that a local variable or a parameter has shadowed the instance field. Shadowing is not good and should be avoided, or it will cause logical errors. In a future video, we will discuss how to solve the problem of shadowing. We will, however, briefly discuss it in the following coding demo. In this demo, we will discuss the scope of variables, fields, and variable parameter variables. And also we will discuss shadowing and how to avoid it. So the first thing is that, as you can see here, we have a class defined, and then we have a couple of methods, and we have two fields. And one thing to notice here is that the fields and width, they have the broadest scope. So the scope of the width starts from the end of this line all the way to the end of this class. All right, the same goes for length from here all the way down. And that's why you can say here area is equal to length times width. You don't have any special keywords to access length and width. They are visible to all of this class, and they are visible for all of these methods. Now that's not the case if you have something like new length. So new length is within the scope of this. We call new length in this case a variable parameter or parameter variable, and we know that its scope is within these curly braces, the scope of that method, right? It's highlighted in that yellow color here. That's a scope of a method. Then another scope of a method. Notice here that these two, they are in that white scope, which expands all the way down to that curly braces. So even these color-coded scopes tells you the scope of each of these attributes, fields, or parameters. The other thing is that now new length is just within that scope, and one way to prove this is that here, let's say for example I say here new length. So you will find that it doesn't recognize that, right? Even though it comes after this, but it doesn't recognize what new length is because it's out of the scope. Now the same thing goes with the area here. Area is a local variable which has, it's very similar to the parameter variable, right? Which has the scope from here to here. The only difference is that a local variable starts not from the curly braces, but from the line it was declared at, right? So that's it. The local variable has the most limited scope because it starts from when you declare it all the way down to the end of the method. The parameter variables from the opening to the closing braces, and the fields, it has the broadest, it's the whole class. So that's the difference between these scopes. So now you know that new width is within this method. I can only use it here. So understanding the scope is very, very important to know how to write the code. Now the second part that we want to talk about is the shadowing. And by shadowing here, what we mean is that what if you have a local variable or a variable parameter or parameter variable that has the same name as a scope, as an attribute. So for example here, I have the two attributes length and width of the rectangle class, and then inside setWidth, I declare a new width variable, local variable, to the setWidth. Now notice here that if I go and try to redeclare double width within the same method, Java is going to complain. It says variable width is already defined. Now that's completely different from defining a local variable for the first time, which has the same name as the field. Java is not going to complain. All right, so that could be good and bad. It's good because now you have that flexibility of using width within the method also, which is different from that width. However, it can be bad because if you do not use it properly, Java will get confused and it will cause logical errors, because now you would think like, oh, I'm setting that width, the field, to that value, but then it turns out to be that width. So you have to be very careful with this. And we will talk about all of these problems. So the first thing is that the first problem would be is that what happens that if you declare, what happens when you declare a double width here, and then you try to set width to w, which is the parameter variable of that method setWidth. All right, so which width is going to be set? All right, now you are hoping that when you say width is equal to w, that this width is set to w. However, what will happen is that this width will be set to w. All right, so let's have a look at this. So inside this method here, inside this demo, I'm going to set the width to 10. All right, I'm going to set the width to 10. And then to prove that it's working or not, I'm going to get width, right? Hoping that, so here's what's happening from the beginning. I'm declaring R1 as a rectangle object. All right, and then I'm going to set the width of R1, should be lowercase, that's better. All right, of R1 to be set with 10. And then I'm going to get the width of R1 to make sure that it was set to 10. All right. Now what will happen is that set width 10 will call here, and then width will be set to 10. And now I'm just trying to show you which width is going to be set to 10. So run this, and here we go. When you declared R1, let's close this one. When you declared R1, length and width were set to 0, then you go and try to set it to 10. But then once you try to read it again, it's still 0. It didn't change. So what does that tell you? It tells you that when you do something like this, shadowing happens. This width will override or shadow this width, and my field is not going to be set properly to 10. Here is another proof. let's call this local variable width. All right, and then try to print that width here. Okay, there we go. Local variable width was actually set to 10. However, the width, the field, is still 0. All right, so that is a problem. Now, another problem that will occur is that if you have your actual set length method has a local parameter variable that is called length, which matches the name of the field. So the same thing, local variable or parameter variable, both of them are going to shadow your fields. When I say length is equal to length, I'm going to repeat the same thing here. Let's try to print local variable length. All right, and then here let's type length. And also let's go back here and try to set length to 100 and then try to get length to make sure that it was set. There we go. So again, shadowing happens. Length is equal to length. What it's going to do is that it says this variable parameter, our parameter variable, which was 100 is equal, or length is equal to length. So you are assigning 100 in the length again, which does nothing. But it's not going to change this field. All right, so that's the problem. Now sometimes, and this is what we will discuss later on, like you don't want to keep creating or generating variable identifiers infinitely, right? Not every time you are dealing with a length, you want to come up with a new length name. Length, len, l, that can be uncomfortable at certain point. And what you want to do is that length is a length, so I want to keep using length here. In the future, we will learn how to tell Java that this length is different from that length. All right, and we will explain it in detail, but I'm going to tell you now, so just you know it. If you want to say that I mean the length that is the field, you start with saying this keyword dot length. All right, so when you say this length, this means I mean the keyword, I mean the attribute of this object. All right, so I mean the length of this object of rectangle, which tells Java that this is the attribute, this is the field, and this is the parameter variable of the method. All right, the same goes here. If I say this dot width, all right, it's going to understand that we mean this width. All right, you see here, once I declared this to be this dot width, or once I identified this to be this dot width, which tells Java this is the field, Java now complains because now we are trying to print width, which has never been assigned before, because now it knows that this is the field, so this width that you are trying to print out doesn't have any value, you just declared it. All right, so here, now it should work, you see? So if I compile this, there you go. The local variable here, length, okay. So in this case here, that this dot length, it was assigned the 100. And that's why when I say get length, I got 100. All right. And the local variable, it was not really a local variable here. That's not entirely correct. That is a parameter variable, right? All right. So the same thing goes here when we say width, right? So let's go back and set that to set width and get width. There we go. So I tried to set the width to 100, and then here I assigned 999 for the width, the local variable. Local variable remained 999, and the attribute width got the value w, which is 100, and now it has 100. All right, so this is how what shadowing is and how to avoid shadowing.